This data stream represents years of observation. The pattern emerging here suggests a significant deviation from the expected model. The data is unprecedented. We're looking at patterns that shouldn't exist outside of theoretical models.
So when we apply the boundary conditions here, the wave function collapses, revealing the inherent symmetry of the cosmic microwave background. This term, this integral right here, represents the quantum fluctuation of the siphon, absolutely critical to the overall solution.
The fine guidance sensors are locked on the target. We are proceeding with the alignment.
Uploading the updated ephemeris data now. Tracking confirms the maneuver initiation in T-minus 30 seconds.
Deployment is the most complex in history. The sunshield tensions, followed by the precise alignment of the 18.
As the universe expands,
the key to understanding the keeping the early universe lies right here. If we adjust the variables for inflation,
when you spend your life studying the cosmos, you realize how little we truly understand about time itself.
We thought we understood the mechanics of the cosmos, but the universe, it seems, is far more subtle than we imagined.
the universe began 13.8 billion years ago with the Big Bang.
Understood.
The telemetry spike on the x-axis correlates with the stabilization burn. We are holding steady at 1.2 gigahertz.
Telemetry stabilized. Diagnostics complete on the X-band. We are go for the maneuver.
the cosmic web is this incredible structure. You have these vast empty voids, and then the galaxies cluster along these dense luminous filaments.
Most people see nothing here, just void. But the data tells a different story entirely. We believe this is the origin point.
This discovery fundamentally alters our understanding of the early universe. The data points conclusively to structures we never before thought exist.
Maneuver confirmed. Reorientation successful. All systems nominal.
Look at that. The transit matches the HSO signature perfectly. It's really there.
We meticulously analyze the data for biosignatures. Yet the search is more than scientific curiosity.
The Nebula is a stellar nursery on a staggering scale.
So we move from the swirling nebula into the main sequence phase. This is where the star spends the majority of its life, fusing hydrogen into helium.
If you look here, the redshift confirms the anomaly.
Which aligns perfectly with the dark matter distribution model.
And the JWST spectrograph confirms the signature.
There it is, the anomaly at 400 microns. It doesn't fit the atmospheric model, which means it has to be a signature of something else.
The energy fluctuations are stabilizing exactly as you predicted, Doctor. But the spike at 400 terahertz, that's unprecedented.
Yes, that explains everything. It confirms the hypothesis.
We stand on the shoulders of giants, you see. Everything we know began right here, in these pages. We've gone from faint smudges on paper to seeing the very first light of creation.
If we look here, the data confirms the presence of complex organic molecules within the nebula itself.
The James Webb Space Telescope is nothing short of a paradigm shift for astronomy. It's truly opening up entirely new fields of inquiry that we hadn't even considered before.
If we apply the accelerated expansion model here, the dark energy component becomes negligible at this scale. As you can see here, the curvature around the singularity drastically changes the information horizon, suggesting a new approach to quantum gravity.
The microshutters here allow for the programmable selection of up to 200,000 objects.
What's the response time if we need to adjust the field?
Less than 50 milliseconds per iteration.
So if we apply the median filter here, you can see how the background noise drops significantly.
Ah, that clarifies the structure.
The cosmos doesn't just hold stars, it holds our reflection. We are, quite literally, the universe wondering about itself.
We did it!
It's incredible.
Look up there, Lena. Look up there, Lena. The lensing effect is undeniable proof of the gravitational wave's origin.
Executing command sequence 4-value Delta. Confirm telemetry lock.
So when we look at this data, the critical implication is right here in the fluctuation anisotropy. This isn't noise, it's the signature of inflation.
Every atom in your body, every element on this planet was forged in the heart of a star. That is stellar nucleosynthesis.
Look at this. Do you see that absorption line right there?
That's not supposed to be there. Could it be water?
It has to be. The implications are huge.
So as you can see, these theories are now obsolete. We have to wipe the slate clean and embrace the new data.
The scale of the infrastructure required for the JWST is truly overwhelming. Row upon row of servers processing terabytes of information.
To see the first stars ignite, to witness the dawn of the cosmos, it's profoundly humbling.
As the gate webs, the light waves stretch.
These equations here, they were the beginning of everything we understand about quasars today. It's humbling to look back.
At these dense knots, gravity takes over.
And then he realizes he left his headset in the centrifuge.
No way. You are making that up. That's hilarious.
The gravitational lensing confirms the mass distribution. This deviation, highlighted here, is crucial for understanding the dark matter correlation.
Imagine the universe as a dark room. Reionization is simply the process where the first stars switch on the lights, illuminating the darkness.
Look at how the gravitational anomaly aligns with the gamma readings.
That confirms the dark matter correlation we hypothesized.
Yeah.
As you can see on the schematic, the trajectory adjustment is minimal. Elena, confirm you're seeing the same data stream on the cryocoolers.
Hubble showed us the universe in a new light, but James Webb, it's the natural successor, extending that lineage.
The Hubble telescope transformed our view of the cosmos, but the James Webb is the next step.
Look at this. I think I found the gravitational lensing signature we were looking for.
And here we see the gravitational lensing beginning to warp the smaller galaxy. The star formation is accelerating rapidly now.
We spend years looking at light from distant stars, but this is the real thing. A piece of another world right here in my hands.
And this, the cosmic cliffs, it's not just beautiful, it's a window into the very beginning of everything.
Trajectory holding steady at L2. Data streams nominal. We are green across the board.
See that faint distortion just below the galaxy cluster?
Yes, I see it. Running the correlation program on the coordinates now.
We're looking at maybe 95% of the universe that we just don't understand yet. That's not a limitation, it's an opportunity for discovery.
This telescope is more than just a machine. It is, quite literally, the eyes of humanity looking into the past.
A stunning breakthrough in our understanding of the cosmos.
The Webb telescope unlocks the universe.
This is the cosmic dawn, the moment the first stars burst into existence.